This is one Dot. Dot has COVID-19, but he doesn't know he has COVID-19. By touching all the objects or interacting with dots, other dots can get COVID-19. So how is it possible to stop this? The solution is social distancing. The safe distance monitoring system is a system to ensure that people always follow the social distancing rule at all times, because it is very difficult to ensure that people adhere to the social distancing rule. There are 4 objectives in this research. 1 is to determine the best angle for camera placement. 2 is to determine the distance between 2 bounding box centroid. 3 is to produce siren sound. 4 to apply transfer learning method, and 5 to deploy safe distance monitoring system at school premises. This is the flowchart of how the SDM system works. It can be divided by 4 steps. Step 1. Input. All the videos are converted into frames and split dataset and sent to be trained. Step 2. Detection algorithm. All the objects in datasets are detected and classified by YOLO v3. After that, pre-trained on COCO dataset to detect only human in bounding box, and transfer learning is used to enhance the result. Step 3. Distance algorithm. Centroid bounding box and distance between 2 centroid bounding box are calculated to determine the distance threshold or not. Datasets are added to violate and non-violate sets. If non-violate, bounding box remain green. If violate, bounding box change to red. Step 4. Output. If bounding box remain green, indicates safe distance. If bounding box red less than 5 seconds, indicates safe distance. But if bounding box red more than 5 seconds, Raspberry Pi instructed the relay to emit the siren, indicates to unsafe distance. Experiment 1 is to determine the best camera placement to capture video streaming. 50 sets of video streaming were captured from different heights and angle point of view are then splitted into frames as datasets. These are part of video streamings that are taken at different places. Videos were then taken at different angles: eye level angle, bird eye angle, high angle, and low angle. All the video streaming will be input in SDM system as datasets. The result shows that the best angle is 45 degree, top front view, and high angle. This angle avoids 2 or more image looks too close to each other or merge. Experiment 2. To apply transfer learning method to enhance the detection of human. The datasets are loaded into the system and trained by YOLO, which stands for You Only Look Once for object detection. All the objects were labeled by creating a bounding box on them. The datasets then trained by COCO datasets, which stands for Common Object in Context, which already contained large samples of pre-trained human image. The system trained the bounding box to detect only human. Transfer learning method is implemented to decrease time learning, and the result is more accurate. YOLO divides the input datasets into grades of equal size and predicts a class on the bounding box. Color green represents there are no object, and transparent shows there are objects in the cell. Many boxes build up to detect the object and ignore box with low score, and select only one box when several boxes overlaps with each other. Common Object in Context (COCO) is a large-scale, ready-made dataset for object detection and segmentation. COCO consists of 1.5 million object instances, 330,000 image, and 80 object categories. YOLO uses datasets already provided by COCO. Transfer learning is a machine learning technique where a model trained on one task is used on a new related task through the transfer knowledge. Transfer learning is using all the classifying information from common object in context COCO to identify new object that related. The main advantages of transfer learning is saving training time and better performance of neural network. These are part of video streaming's output with the bounding box. As you can see, there are red bounding boxes and green bounding boxes. Here is the result when the SDM system applied YOLO V3 without transfer learning and with transfer learning method. The accuracy is 60%. With transfer learning method, the accuracy is 90%.
Experiment 3. To determine the distance between two centroid bounding box. Centroid bounding box is calculated by using centroid tracking algorithm. Then, the Euclidean distance between two centroid bounding box is determined. A predefined threshold is used to check either the distance is less than 1 meter or not before adding to violate and non-violate sets. Results are, if distance is more than 1 meter, bounding box remain green. If less than 1 meter, bounding box change to red.
Lastly, experiment 4 is to produce siren sound when people get too close to each other in public areas.
The result can be seen in A, as the bounding box are green. This indicates safe distance. In B, bounding box are red. If this continue more than 5 seconds, the system automatically sends instruction to RPI. When Raspberry Pi received the signal, it instructed the relay to activate the alarm and siren sound.
Future works. Different detection and distance algorithm will be improvised. Built-in GPS, Bluetooth, LTE and Wi-Fi transceiver, faster CPU and real-time OS. Cloud-based data monitoring system and produce an application and notification will be sent to school authorities and teachers' handphone. In a conclusion, the SDM system is a system used to monitor people so that they will maintain the safe distance with the accuracy of 90%. And that is all from us. Thank you.